Hi, everyone. Welcome to our community stream for the month of April, end of April. And today I'm joined with Joel Dice from Fermion, who is going to talk a little bit about async. Uh, Joel, would you like to introduce yourself and some of the things that you do?
Yeah. My name's Joel. Been working at Fermion for about a year and a half now. Am particularly enthusiastic about improving support for various programming languages in WebAssembly. Was enthusiastic about it well before I started at Fermion, and have invested a lot of time in improving Python support. Have recently started working on C# support or helping out with the ongoing work that's already in progress there. Um, Also curious about how where we can take Java and Ruby and a few others. So been working on that, and then also working on some of the newer features of the component model designed to support WASI 0.3.
Amazing. Yeah. So today, our agenda basically looks like explore all the cool things that Joel's been working on, and that's a broad set. So the last time you were on, you were talking about componentized Pi, and then we even delved in a little bit deeper and showed some of the interesting techniques that you had to use to be able to make Python dependencies work well in the Python ecosystem. But this time, we're going to totally change gears and talk about totally different topics. So thank you, Joel, for coming on. I'd love to talk a little bit about some of the news and the example that I saw you created for C# using WASI HTTP. Do you mind talking a little bit about that?
Yeah. So yeah, this is very brand new. I was asked by my boss about a week ago to help out with some of the C# stuff, partly because I had experience implementing a key feature of the component model, namely resources, which is basically impossible to avoid when we're talking about WASI, WASI HTTP, WASI CLI. It's all based on resources these days. And so it was a key part of, and it turned out the last major part of the puzzle for generating bindings for C#. I had already had experience with implementing resources for Rust and Python and JavaScript. Had started to get the hang of it. I was pretty new to C# and actually had to go on MSDN and kind of learn some of the basics. And kind of how interfaces and classes work and whatnot. Coming from a Java background, it's very similar, but not totally the same. The good news, the upshot of it all was after a week of kind of intensive effort and a lot of help from others, James and Scott and others kind of working on C#, Timmy. Um, we were able to kind of get all that working and was able to use that new bindings generator to create a WASI HTTP example. Very simple hello world example, but just to prove it works. Um, if I had a link handy, I would paste that in. I'm not sure if people can see that, but maybe we can add it later to the notes. Um, but yeah, so that's great news. It basically, now that we have resource support, essentially the C# generator is done. I'm sure there's ergonomic tweaks that will come, over time, but you can use it to target any part of WASI, the WASI CLI world, the WASI HTTP proxy world, and future versions of, future, WASI key value, WASI cloud types of things as well. So yeah.
Yeah, I got a link.
Oh,
I moved
perfect.
quick.
Good work.
Yeah. What does this essentially mean? We've got you say you've got a bindgen for C#, and you're able to make a simple WASI HTTP demo, and you called it Hello World. But I just want to say, from my experience, when we've been building these things, the milestone is usually some intermediate Hello World, and then we hit the WASI HTTP because WASI HTTP seems to hit like all of our edge cases. It finds a way. So in my opinion, this is huge. This is really exciting. It takes it pretty far. Albeit, it is the initial example for it, and you got it going in a week, which is promising. That means we've got some well-established patterns now for supporting these languages, and maybe with BindGen can be that much easier for other people. Maybe we've got a playbook we can start sharing. That is exciting. Do you know what's next for C Sharp? What's coming?
Yeah, good question. I'm still kind of getting in the sort of the swing of things. I do know one of the limitations of the repo, that Hello World example, is it only builds on Windows currently. The AOT, it's using this really cool new LLVM based AOT compiler, but and there's nothing fundamental that ties it to Windows. It's just that, because this is all very much work in progress, we haven't gotten around to Linux and Mac support. So that would be a pretty critical one, I think, to make sure that everybody can, build these things, build these components, regardless of operating system. Um, and then I think the other big thing, I opened an issue a few weeks ago on the one of the .NET repos, I think the main .NET repo, about integrating WASI HTTP support into the built-in standard library for C Sharp. Basically, it has its own built-in way of doing HTTP, and essentially porting that over to WASI HTTP so that C Sharp developers familiar with that interface can continue to use it and have it just work on WASI. And there's already support for WASI Preview 1 in terms of accessing the file system and that sort of thing. So as long as we continue to do this Preview 1 to Preview 2 adapter like we use in other ecosystems, that's all going to continue to work. The other big thing, though, that we want to see happen is WASI socket support, which of course was only at least very limited when it came to WASI Preview 1. And so we want to, it's much more expanded, it's much more flexible now, and more full featured in the Preview 2 timeframe. So we want to make sure that that's reflected in the standard library as well.
Excellent, awesome. So more to come in the C#.NET realm. There's more effort and work there, but it sounds like it's moving along really well. I can give a little bit of an update on the Go side of the world. Damien, who's a recognized contributor at Fastly, he is merging in the WASI CLI support for the component model into TinyGo. And that's on the main dev branch is where it's going to land first before there's a release of it. But I think that's extremely exciting. And I hinted at the WASI HTTP being an edge case because guess what needs to work a little bit better over there. So right now it's WASI CLI world, and then WASI HTTP is ongoing. But I expect all of those to be shaken out over the next month, which is huge. So we've got many different languages now that we support. So I think that is enough for the round of updates. I usually try to highlight the cool new things that are coming in. Of course, Wasm Time 20 is released. Go check out its release notes. I'm not gonna bring up that one out of all the others, but I think more than anything, what we're seeing is an extension of what we can do with guest languages, which leads us into Joel, what is ISIS WAFA and why should I care? And maybe why should I not care?
Yeah, great question, and well phrased. Yeah, so ISIS WASPA, it's a first of all, it's an acronym for I sync, you sync, we all sync for async, which I was just ridiculously pleased with myself for coming up with. But it all basically, so being serious though, it addresses a limitation, a known expected limitation of WASI 0.2, which is that, and WASI 0.1 for that matter, which was that the async support, basically the support for doing concurrent IO operations, multiple concurrent IO operations, is not composable. And what I mean by that is if I have two components, both of which want to do concurrent asynchronous IO operations, and I want to compose them together, It doesn't really work. And the reason is it comes down to this basically primitive operation called poll, which basically you can pass it a list of pollables, which represent all the operations that you want to do and you want to wait for to happen at once. And only one of those two components that in this example would be able to actually call poll at any given time, because as soon as one of those components calls poll, the other one, it's blocking itself and it's blocking the other one as well. And so the only way they could actually sort of cooperate would be if they had some pre-established protocol for, say, component A saying, okay, component B, you're the one who's going to call poll. I'm going to give you my pollables, and you can combine those with your own pollables, and you can call poll, and I'll expect you to do that. But of course, that's not very symmetric. You have to establish ahead of time the relationship between these components, and it gets a lot messier if you've got 4 or 5 components all composed together, or if you're creating an HTTP router, and each of your routes are handled by a separate component, and each of those components wants to do outbound, SQL, queries or whatever. Gets really messy. So the idea was, the plan all along was for that 0.3 or some later version of WASI and the underlying component model to have built-in composable concurrency support. And that's what ISIS WASFA is designed to preview. And the idea I had a few months ago was to see how much of the guest experience, the experience that a person using, like the C# SDK or the Python SDK, or I'm sorry, the C# WitBindGen or Componentized Pi or the new Go support, what sort of experience should they have when WASI 0.3 comes out? And can we deliver most of that or something very similar to it without having to actually implement the nitty gritty of what Luke and others have kind of proposed as being component model async? And it turned out, yes, we can. And the value here being that we sort of get early feedback and sort of early understanding, a vision that you can actually run and write your own applications against, without actually sinking all the time that we ultimately need to, but sinking all that time into actually implementing it and potentially then learning, oh, we got something wrong. So it's sort of like buying down risk with this concurrency effort, getting early feedback rather than waiting till it's all done and then getting that feedback. So.
Yeah, I just dropped a link if anybody's interested. Luke gave an amazing talk at WASM.io where he also had a very witty name for the talk, and he went through sort of the design and all the reasons and the principles for how we want to do essentially native async. And I guess to summarize some of the problems that Joel enumerated is that composition is really hard when you're talking about sort of a pollable system is what we have, but if you're not familiar with any of it, think of it like callbacks. And you need a callback table effectively, which means you need one table, and that's kind of hard when you've got any series of composition of components. So that all makes perfect sense to me. And so with ISIS WAFA, how does it specifically solve this problem?
Yeah, well, I'm a little hesitant to get into the details of how it does it, because it's all going to be obsolete once we have the component model. And as we'll talk about later, I'm about halfway through doing the real thing, and so the fake, hacky thing is less and less interesting. But I will say that yes, in a nutshell, at a high level, it's essentially moving that poll operation out of any one of those components, because of course, yeah, part of the problem here is deciding which component is going to call poll and when and how it cooperates with the other components, and remove that responsibility entirely from any component, so that essentially the host is calling poll on behalf of all the other components. And so if you have 5 components and they all are essentially, all they have to do essentially is make async calls to imports, and then the host will basically say, okay, I'm going to create, for each of those async calls, I'm going to create a task, and I'm going to essentially I'll return before I even have a result for any of one of those tasks, I'm going to go ahead and return control to the components, and those components can either generate more tasks before they're done, or can return control back to the host. And we do that in such a way that we allow essentially all the components to basically make all the async calls, kind of queue up all those tasks, and then once they have returned control back to the host then takes all of those. You can think of these tasks as the equivalent of pullables, and waits for the first of those pullables to be ready. And once those pullables are ready, then or tasks are ready, then it calls back into the respective components, having kept track of which components were interested in which tasks, and asked if they can make more progress. And that may result in further async calls, which generate more tasks, which generate, which allow the host to pull again, and we basically iterate until all the tasks are done, and we have our original answer from whatever original host to guest call kicked all this off.
And so Isoswafa gives us the sort of intermediate solution that lets us solve it in the way that you just described.
Yep.
But circling back to my first question, maybe why don't I care?
Yeah. Yeah. Well, so uh, like I said, it's a hack. My intention is that Isoswaspha is sort of a proof of concept, a prototype. Maybe you could think of it as a polyfill, but I think that's glorifying it more than it deserves. It's really more of just, yeah, that proof of concept, showing people that async. Part of it was honestly just to sort of demystify it for myself and for others. Some of the folks I've talked to were really intimidated by the idea of, they're still trying to get their heads around the component model as it is, and now as we add async to the mix, it starts to become, you know rather intimidating, which I understood. It was intimidating me, and so I wanted to kind of show that actually, from a guest perspective, it's actually very natural. If you're used to doing async away in JavaScript, Python, C Sharp, Rust, the generated code should look exactly like you would expect it to do these IO operations. And so, to show that, and but to answer your question, it is based on a hack. The underlying implementation looks very little like what we're actually going to end up with, and what Luke has proposed in the presentation you linked to. Uh, and so over the past month or so, I've started work on the real thing, which essentially is all the work that I sort of postponed, by doing Isoswaspha, which is to update WIT-BindGen, WASM tools, and WASM time, as sort of a first reference implementation for this async support. And making good progress on that. And in fact, there are some features that now this prototype has, which Isoswaspha does not. The most compelling one being the ability to use any combination of async and sync composition. So say I have a function that I want to do, I have a component A and I have a component B, and component A wants to call a function in component B. Now, if you're familiar with the terminology of function coloring, some
Mhm.
people have kind of complained about, okay, if I have an async function and I want to call it from a sync context, how do I do that? Or if I have a sync function and I want to call it from an async function, how do I do that? Uh, and the good news is, with the component model, that basically goes away. There is no coloring. There's no need for awareness. So any combination of component A importing an async function and component B exporting a function and hooking those up. It could be async to sync to async, sync to sync, of course, which always has worked. Or now, what was the fourth one? Sync to async, or did I say that already? Async to sync. Uh, any of those combinations, they work. Most of those combinations are actually pretty straightforward, you might imagine. Like doing a synchronous call to an async function just means the host is going to sort of interpose itself and say, okay, well, until this async function actually completes, like it yields a result, I'm not going to give control back to the component that called it. In the async to sync case, it gets a lot more interesting, because now we want to do an async call without blocking the caller on a synchronous component,
Mm.
a synchronous function in a component, another component, and that gets pretty interesting because traditionally in traditional programming language, that would be a no-no. You don't want to call a synchronous function because you'll block whatever event loop or executor is kind of driving all this. But because the host knows about what's async and what's sync, and what the right thing to do is in all these cases, it can actually manage this uh, the way you would want it to, which is basically you do the async to sync call that kicks off the synchronous call. That synchronous call does well. If it doesn't do any blocking operations, then it's simple. Then it'll just return back more or less instantaneously, and then you can return a result to the async caller. If it does do a blocking operation, then we need to uh, we basically need to mark that component as not being reenterable, but we can return control back to the caller, and then the caller can do other, async operations. Maybe do an HTTP request or a, file access or whatever. And if it does another call, async call into that same component that we had to suspend, that's fine. We're not going to disallow it. We're not going to trap. We're not going to, complain. We're just going to say, okay, well, you already have one async call, or I'm sorry, you already have one call outstanding, one task outstanding. Because I can't safely re-enter the synchronous component, I'm just going to apply back pressure and say, okay, well, I'm not even going to try to start that second call until the first call finishes. But the caller can continue to do stuff and not be blocked and queue up more tasks, etc. Um, that was a bit of a mouthful. Did that kind of make sense?
It made perfect sense to me. Let me play back and my simple terms. We've solved the function coloring problem, allowing us to do component composition and call interfaces from async to sync and all the other combinations in between.
Hmm.
There are apparently four of them. We're not going to enumerate them again. And what is so powerful about this is that you basically have a fully asynchronous framework that is compositional across language boundaries, and we're able to generate bindings in all of these different guest languages that feels native to those languages. That's huge. So we're on WASI dot two, right? And we've been saying that, hey, that native async, that's a problem for WASI Preview 3. How are you able to do this work now? How are you able to get it started?
Well, yeah, great question. Again, I think ISIS WASFA and Luke's latest sort of thinking and presentations have opened people's eyes to actually it's maybe not that intimidating and difficult to do to implement or to understand from a application developer's perspective. Um, and so and the good news is we can kind of develop, say, our vision for WASI's HTTP 0.3, to name an example, an important example, uh, in parallel with 0.2.x development. We can continue to incrementally update, the WASI 0.2 series of standards while also starting work on 0.3. And honestly, it's my personal goal to see 0.3 come sooner rather than later. And part of the reason I'm doing this is, to prove that we can do that. That there's no technical reason why we can't do that. Um, and uh, and also, just again show that, because there was originally some pushback about having async be part of 0.3 at all. And so I hope I've actually reached the point where I've convinced folks that yes, it can be, it should be. And not only that, but 0.3 isn't that far away. So that's where I'm coming from. Yeah.
Very cool. Okay, so when we were at the Plumber Summit, you showed off and introduced ISIS Waffle for the first time, which blew my mind. Then we talked about what we would want inside Preview 3, and Luke went through basically a Google Doc that was 2 pages of just straight bullets of all the things that he wants us to consider, and I think the way that he described it was a buffet menu of what we could pick as important things for this. So I'm not saying that Preview 3 only includes native async, but I think that that is definitely a hallmark feature of it. So that is incredibly exciting. Now, I saw some of your changes land inside Componentized Pi. Was that getting a feel for the more hacky solution on the gas side because you can make that work today?
Yeah, it is. So it's got built-in support for this ISIS-WASPA thing, but the intention is that that will transform or be transformed into proper component model async support, and that was part of the goal of ISIS-WASPA. The further up the kind of the stack of abstraction here, the more ISIS-WASPA starts to resemble what we actually want to land on for the real thing, and so I don't anticipate that the bindings generator, whether it's for Python or for Rust, which were the two ones I did for ISIS WASPA, that they'll change particularly substantially versus what we'll end up with. So
Excellent. I
uh,
mean, that basically means you've done a good chunk of that work. So that's huge. Okay, I have several more questions I want to ask, but actually somebody else has a question, so I'll bring that up. Will languages that rely on Preview One and the adapter have to migrate fully to dot two before adopting dot three async? And is there a feeling of what that migration might look like?
Yeah. Yeah. So, of course, the scope of Preview One is POSIX kind of stuff like environment variables, very limited sockets, file system stuff. I'm trying to jog my memory. Maybe you can help, Bailey.
Sure.
Did was are in Preview 2 or 0.2, file system operations are basically all async. There's like a blocking write and flush
Hmm.
function for but it's just sort of syntactic sugar over kind of the more the async oriented thing, and it's sort of async first, so to speak, uh, within the narrow idea of what async means in 0.2. Our file system operations in Preview 1, were those also async first, or because was everything pullable, or I'm just trying to remember.
Pullable, I don't remember being a
Yeah.
concept in
Yeah.
Preview One. Now with dot two, yes, everything in the WASI file system proposal essentially builds on top of the stream type of WASI IO, which
Yeah.
is as you know built on top of pullables.
Yeah.
I know that there were some different designs for that, but I am pretty sure it was blocking
Yeah.
because I remember problems that I had when I
I
was deploying in a database.
yeah, I think if you did a write, you basically on a file descriptor you blocked, or you read on file descriptor you block. You could also though pass file descriptors to the pull one off, I think, function. So there was that ability. But anyway, that's a little bit on a tangent. To answer the question, migrate fully. I think yeah. This is a nuanced question because I was just talking with Luke earlier today about there's a desire that uh, runtimes should not need to implement the full component model in order to support 0.2 or 0.3, and possibly we would have sort of a variation on WASI that basically worked at the module level that used the same canonical API and everything that the component model does, but that doesn't require the component level kind of abstraction, and wrapping of modules. And so in that vision, I think there is room for this idea of like a module based transition, or ability to use these APIs. Again, you still have to, at some level, implement this canonical API. That's kind of like table stakes. Similarly, how you had to implement the WIDX API for Preview One. But assuming you can do that, I think you could probably but you don't have like the component support and whatnot for 0.2. I think you could probably do this async lifting and lowering as long as you're following the ABI for it. Um, it's a real good question, and I'd have to think about it some more because I've got my head in the component world and just assuming everybody's ready for it. And but I understand that tool chains are still kind of adapting to it.
in
Um,
in the realm of bad ideas only. I totally see a path of I could take a WASI Preview One module and have a tool that says this is the Preview Three adapter, but all that tool is two steps. It runs the Preview Two adapter to go from Preview One to Preview Two. When you do that, it outputs a component. All of that happens automatically today. I don't remember any issues with any of the languages that we created that you went from preview 1 to preview 2, and that adapter just didn't just work.
Yeah.
And actually, many different language toolchains already still use that adapter. Like we're doing that in the TinyGo space that we were just talking about earlier. It's actually still using that adapter, using that to go and output a component.
Yeah.
So then the process would just be, okay, run the .2 adapter, and then run our .3 adapter, which would be doing the async lifting and lowering, but in the context of a component. And then if we're talking about, okay, but we've got these other tool chains, like say embedded systems that need to eliminate all abstractions as best they can, and also are running potentially on runtimes that only support modules. It's a little bit more complicated, I think, to solve this problem, in that once we introduce native async and it is handled by a system, by the component model and the design that Luke put forth, that's when it gets a lot harder to go from a component back to an OG module that is doing shared everything linking.
Yeah, agreed. I think the one other thing I would mention that just popped into my mind is one of I should clarify that what I'm doing right now, what I did for ISIS WASFA, and what I'm doing now with kind of this MVP implementation that I hope I'm anticipating will be the MVP component model async support for WASI 0.3 is not the end of the async story necessarily. It's actually only part of it, and one of the features that I expect will be post 0.3, although I won't claim to predict the future here. That is a built-in called canon.wait, and
Mm.
it's basically a component level equivalent of the pull function, which I think would be a very important feature of an async aware 0.1 to 0.3 adapter or 0.2 to 0.3 adapter. And the idea here is that you are able to call pull.wait. That's the thing you can block on, but do it in a composable way. Earlier I said like pull, basically blocking on a pull function is sort of anathema to what we're trying to do here with composable async. But once you start to allow reentrancy into a component, a component that's otherwise synchronous, meaning you can actually have multiple outstanding calls in progress while earlier calls were blocking. That does open up the ability to do this kind of another more traditional pull mechanism, which of course things like any software written to target select or epull or one of the other similar abstractions is expecting. So we do want to support that eventually. Whether that's part of 0.3 and thus enables more traditional applications to do this, participate in this composable async, is somewhat of an open question, but it's certainly something that we're going to want to support eventually.
So I guess my bad ideas answer is it'll totally be possible to go from WASI Preview 1 to Preview 3. Am I going to have a dirty hack underneath? Maybe, but nobody needs to know. It should just work. Now, there are other questions that people are asking about, like, if I can make it. What Joel's mentioning is that we've been also exploring in the Bytecode Alliance space in context of, hey, there's a lot of these runtimes that exist for WASI Preview 1. So is it possible to go to the future with all the latest stuff and then go back again and go back to what we previously did with modules? And that, my gut is that is going to be much more of a challenge once we introduce async into the equation.
Yeah, I agree. I wouldn't say it's out of the question either, but yeah, I agree. It's an interesting thing that we'll have to think about and talk about. Yeah.
Cool. Well, folks, we are obviously live, so if you want to ask us any questions, please drop them in the chat. I'm going to keep quizzing Joel because I have a million more questions that this one raised. But so Joel, you said you were about halfway through. The changes that you made were to WIT bindgen, which is usually just guest language side generation, But you also mentioned work happening inside WASM tools.
Mhm.
The cool thing about WASM tools is a crate that lots of us all over the ecosystem embed in a lot of different contexts. For the use case that you were building for WASM tools, was that something that you were expecting to include in host runtimes like WASM time, or was it still focused on the guest side?
Yeah, well, so what the async, so there's a whole new sort of a, well, I shouldn't say whole new ABI. It's an incremental sort of expansion of the current canonical ABI
Hmm.
for the component model, and in particular, the component model has a binary specification and just like the core WebAssembly, it's got a binary specification and then a WAT or WebAssembly text representation, and so one of WASM tools many jobs is to be able to essentially encode and decode those representations and translate between them and that sort of thing. Um, and so that's the work that I had to do based on close collaboration with Luke, and Luke actually, by the way, has on the component model repository under the WebAssembly org on GitHub, has a branch that kind of somewhat formalizes what I've been implementing. But it basically, so there's this concept of lifting and lowering uh, in in the component model, and it's the lifting idea is basically taking a core WebAssembly export and lifting it into, and this core WebAssembly import export being core WebAssembly only can deal with integers and floating point values, and lifting that into a component model level type, function type, which deals with strings and records and resources and that sort of thing. And likewise, for imports, those can be lowered. So we can basically take a component model import and lower that to a something that a kind of a LLVM or a code generator can support and translate to that programming language's representation for those types. And so now with async, we have a way to do async lifts and async lowers, as well as synchronous lifts and synchronous lowers. And so we have had to update the specification for the component model to indicate how to represent that both in binary and text format. And also there's some supporting intrinsic functions that we're introducing, similar to the intrinsic functions we added for resources, being able to create and dispose of resources. Now we have intrinsic functions for that facilitate lifting and lowering, and in particular allow us to essentially marshal this protocol, or let's see, facilitate the protocol for the life cycle of an async task. So, for example, when you are actually making an async call, this can actually involve multiple calls, uh, uh, both the original call, and then you'll get a status back, and that status will tell you whether a result is available or not. And if a result is not yet available, then you will be called via a callback, which is one of these intrinsic functions. Um, to be notified when a result is available, and and I'm going into maybe more detail than we need here, but then the other aspect is even once a result is available, that doesn't mean the task is done, because it may be that the implementer of that task has more work to do. And a canonical example of that is for WASI HTTP. The idea is that you can return a response uh, for, based on processing a request before you've actually generated the body and streamed the body. And so the idea here is that a task can actually have a lifetime longer than beyond when it actually yields a result. Similar to, if you're familiar with coroutines in various languages, this is sort of a follows in those footsteps. Um,
So, are you thinking this piece? Is it Does it allow us to use things like coroutines, like in Go? Like I would be able to generate this now and interact with it.
Eventually, yeah. So Go is sort of a special case because it has Go routines are essentially what you would call stackful coroutines, which is I would contrast with stackless coroutines, which is what you generally get for JavaScript, C Sharp, Python, and Rust. And eventually, we do want to support that also. That does require some that kind of is what I alluded to earlier, where we have sort of a callback-based API which supports the stackless case, and then we're going to have essentially a reentrancy oriented ABI for languages like Go and Java, which have more stackful oriented coroutines. But I went off on a bit of a tangent there. To answer your original question, this is what I've been doing with WASM tools: is adding support for these for generating and parsing component files that use the async ABI.
Got it. Okay. If you don't mind, I'm gonna pull up a quick diagram that we've done before, just so that people can understand kind of in the scope of what we're talking about. If you have a single component instance, the reality is that components themselves wrap core WASM modules, right? And so what Joel was talking about, where the lifting and lowering is happening, is where these yellow lines are.
Mm-hmm.
And that's also where we have these canonical ABI built-in operations. And
Yep.
so Joel is basically what he's talking about. What he's doing are these yellow pieces.
Mm-hmm.
That might be way too simplistic of an explanation, but I wanted to have some type of visual for folks. And when we're talking about lifting and lowering, what we're really talking about is being able to leverage the core WASM specification, having a canonical way, aka the canonical ABI way, of being able to then talk about these high level types across different component boundaries. And that lets us do cool things like virtual platform layering, where we're able to snap these two different pieces over different APIs together and call each other. So I just, in case we got too lost in the sauce there, just kind of have this in your mind as the layer that we're talking about. That's really cool, Joel. Thank you.
Yep.
Okay, so you say you're halfway through, so there's more work to do.
Yep.
Although it sounds like a significant portion of the design space has been determined and solved.
Yep.
What are the open questions that you have right now on the project?
Yeah, I think Luke and I are still nailing down the details of exactly how we represent the ABI. We've actually we've some of the work I've done already is a little bit obsolete. It's going to be pretty trivial to change, but we kind of decide the nuances about how we communicate task status between the guest and the host. Trivial details that we just want to make sure it's all optimal and makes sense. We've iterated on. I think one of the big open questions in my mind, just because we haven't gotten to it yet, is if you're familiar with WASI.io, it was sort of intended to sort of anticipate what we're going to build into the component model for async. And so there's this idea of input streams and output streams, which are going to be essentially condensed down into a built-in canonical stream type, which kind of basically we're moving it out of the WASI layer down into the component model layer, which was what we planned to do from the beginning. And one of the questions there was, how do we represent WASI.io error, which is basically the error, if you're reading from a stream and it, say, closes unexpectedly, some sort of error should be generated. And so if we're moving streams from the WASI level down to the component model level, then any errors that streams can generate should also probably be moved from the WASI level down to the component model level. It would be a weird thing for component model to depend on WASI and WASI to depend on the component model. So we're going to have an error type of some kind there, but we also don't necessarily want it to be like some big enumeration that handles all the possible errors that any sort of API could want. And so the conclusion we came to was, okay, it's going to be some sort of error that can have some dynamically attached metadata attached with it. And then for WASI HTTP, you could get something that was specific to WASI HTTP. For for some WASI Cloud key value thing, you could get something specific to that. Or if it's for file system, you could get some metadata for that. And so how exactly we represent that and how you can sort of get the dynamic part of the error out of the error object is a bit of an open question.
Interesting. Yeah, I think that'll also play pretty strongly into WASI Cloud APIs are some of the ones that you've been collaborating on as along with Taylor Thomas and Kate Goldenring and several folks from Microsoft, including Masaka. So we're seeing the need where we have to define a lot of different types of errors because there's a lot of interesting issues that can happen when connecting over network devices like Plop Store versus like the very tight set that we would have for maybe a file system. That those errors have been established for a very long time. So I think being able to allow us to have these dynamic errors, but have a built-in type. And I think the way that the spicy way that Luke described this is I want to eliminate WASI IO. That's my goal with Preview 3, because all of those abstractions are really for building, kind of async, but in not the best way. And we can make that all be part of the component model. And I think that all makes sense. And yes, I have that open question too. I really want to know how the errors are handled because I think that's going to be the tricky bit. The other tricky bit would be potentially logging in the component part. I think is the other. I think that's an open question, and I think if folks have done a lot in the design space before, feedback welcome. Is there anything else that we needed to hit that we probably haven't covered on this topic?
I don't think so. I mean, I guess I would just mention that the next thing, I basically, the async lifting and lowering stuff is more or less done, modulo a few details, and hoping to get that some PRs opened in the next few weeks. The big thing that's left to do, the other half, so to speak, is stream and future support. Streams we talked a little bit about them before, but it's a generic type, so it can be a stream of U8 or it could be a stream of some resource type or a stream of strings or whatever. We're going to have that support, and the basic way it works is you call this stream new intrinsic function or built-in function that will give you two handles back, one to the read side and one to the write side. And so then you can pass the read side to some other component if you want to, or some other part of the component that you're already in, and essentially do this async. You can spawn an async task. This kind of goes back to, a component can be in a state where it's yielded a result, but it's still got work to do. This spawn task of actually streaming to the writable end of a stream is an example, is a very common example that we'll see of doing that. And so that's going to be in place. And then a future, this has been an area of confusion for folks because people were thinking like, oh, every async call that you ever do, that's going to generate a future, right? And the current way we're thinking of this is not necessarily. A future is more, you can think of it as sort of a degenerate stream, or at least that's how we're using the vocabulary here. Whereas a stream, you can basically feed it as many values as you want to until you decide it's done and you're done writing it and you drop the handle. With a future, it's just sort of what you might call a one-shot stream, which means you can feed it one value and you're done. You can't feed it any more values. And then of course the receiver only expects to get one value. And so it's basically, again, it's this idea of sort of decoupling the write end and the read end so that you can pass the read end around, as necessary and hold on to the write end, which is a little bit different from doing an async call. And it actually tends to be very complementary to being able to, call an async import, which in doing so, you might pass it the readable end of a future, or you might receive the readable end of a future, and then allow some other task that was spawned by that operation to feed you a value sometime later. And this can be an example of where this is very useful is trailers, where in an HTTP request, which is actually, I'll be honest, I hadn't even heard of this feature until I got into WASI HTTP. But it's sort of the opposite of headers. The headers come before the body, the trailers come after the body, and in order to represent when you're creating a request or a response, you need to be able to give it a stream represent the body, and then you need to give it the readable end of a future for the trailers, because you won't necessarily know what the values of the trailers are until you've written all of the body. Um, so it's not actually going to come up that often, but when it does come up, it's going to be very useful.
Very interesting. Yeah. And actually I really love some of the simplification that you've proposed for the WASI.3 version of WASI HTTP. Kudos on that. I think I too was new to trailers, but I also knew that was one of the more complicated pieces that we had to solve to make WASI HTTP work well. And in a lot of ways, at some points, we called WASI HTTP a high level API because we're not exposing like a socket, like a raw socket. We're saying, hey, here's this this interface, this HTTP incoming request and outgoing response. Here are the different ways that you can work with it, and then that allows the host to sandbox it in good better ways than before, where it's just like, here's a socket, go for it. But the downside there is that we've basically fully implemented a lot of the aspects of the HTTP spec. So if you ask me, who's used to using more higher level HTTP client libraries, that's a pretty big bear to look at and work with right now. And I've been seeing a plethora of different solutions crop up across the ecosystem for how to have easier ways of interacting with WASI HTTP. I also know of an effort happening in the Go space, for example, that's like, okay, let's build on top of Net HTTP, use that API, and then underneath wire that to WASI HTTP, and we're going to see that everywhere.
Right.
But we also, at the end of the day, you still have to have these types of problems solved, right? And it has to be happening underneath. And so I just said a bunch of words to say, the average developer, if that sounded really intimidating to you, that it's okay, because all of these libraries are going to have what they need. They're going to implement it, and then you're going to have a really simple, client request type interaction that you're already used to and is idiomatic in your language. It looks like we've got another question here. Any research on debugging and integration, like what these WASI APIs would look like? Chrome's WASM debugging and stepping into C++ using Dwarf was super interesting, but guessing it's unlikely to be component model compatible. Okay, I can break down some of these, but Jill, you're going to have to fill in the gaps that I don't know. The Dwarf style debugging, when people say that, they are usually talking about the gas side. But there's also been active work on being able to have Dwarf debugging of the runtimes. And there's a huge effort that's happening in that right now for WASM time. But I'm going to say we're not going to talk about that. We're going to talk about the guest side. Chrome, but actually the ones that I saw at first was actually the Mozilla team. So I want to make sure I give credit where credit's due there. They generated a source map debugger and then allowed you to step through your C++ code. And it's actually how I debugged a lot of my C++ code in the 2010s. So that was always a little dicey, sometimes the performance, I could totally tank things when I was using such a large source map, but okay, let's say that it all works and it's nice. Is that debugging support compatible? I would say not really, in that I don't know that works with the multi-memory proposal is working in Chrome. And so I think that if you wanted to use exactly that, what you would do is take Jco, transpile your component, and you would be able to exactly use some of this functionality in your browser and step through things. Is that the best experience? I don't think so. I think there's a lot better that we can provide, and I've seen several different proposals that have been happening. Joel, is there anything that you've seen on your side around debugging that you would share?
Yeah, I'm not well, first of all, I would echo what you were saying. I think with via Jco, I think actually you should be able to have at least a comparable experience to what you've had debugging core modules, in Chrome. I don't know of, I can't think of any reason why you wouldn't. Obviously, again, you still have to build with your dash G flag or whatever, make sure that the deep dwarf symbols are added to your to your module, but there's nothing in the componentization process that should strip that out, so that it should still be there and available when it's run in the browser. Um, I do know that Nick Fitzgerald has been leading the special interest group in the Bytecode Alliance for debugging. I went to the first few of the meetings, but then had too many meetings on my calendar and had to drop them. I know they've definitely improved the debugging support where in WASM time, where for cases where you actually want to debug both the guest and the host simultaneously and be able to kind of step through both of them, and that works better than it ever has. For cases, but of course debugging, it's a huge range of things. Like if we're talking about JavaScript and you've got a JavaScript interpreter in WASM on a WebAssembly host, there's multiple levels that you might want to debug there, right? You might want to debug at the JavaScript level, you might want to debug at the guest WASM level, you might want to debug at the host level. And I know there's people interested in working on all those things. I think right now, what they've been focusing on is what traditionally WASM time at least has been good at, which is kind of the WebAssembly level plus the dwarf symbols to translate that into kind of source level. Um, but yeah, maybe that's Nick would be a great guest for a future stream to kind of expound on that.
Oh yeah, definitely. And I know there's some CLI tooling to make that a little bit easier. And yeah. We also have a bunch of different places that folks can get involved. If you're interested in joining any of these SIGs that Joel mentioned, we've got SIG debugging, SIG guest languages, and then we obviously several more. But if you are interested, and I can't type and talk at the same time, it turns out, so please forgive me, but here is the link to the Bytecode Alliance meetings. I'm gonna just plop this one up. This is where you can see where all of our different meetings are happening, and then within there's also a Google Calendar where some of these are on, but we're working on migrating all of them over so that we get better visibility. And there is also the Zulip chat, which is great. So I'm going to plot this up as well. That if you're unfamiliar, Zulip's where you can catch all of us. It's where most of us hang out, and then we have lots of great conversation over there. And I think that there's a million different directions we can go to answer this last question. I want to throw in one other cool idea that we've all talked about, and I've noticed that we've started expanding that design space to cover a little bit better on using unit tests with tools like WASI-Virt. So I prefer writing I don't do this in Rust, but in every other language, I almost always do test-driven development. And the way that I debug anything, like somebody sends me a bug report or something, I usually try to write a unit test that sort of walks through it, and then I set up my debugger and I figure out what the heck's happening. So having that type of experience is what we want for everybody working in the WebAssembly ecosystem. There's a really interesting and awesome opportunity with what the component model for the way that we can virtualize and mock WASI APIs. And so there's a tool that is designed for virtualizing WASI APIs called WASI-Virt. It's in the Bytecode Alliance. It's really neat. And there's a conversation happening right now in our Zulip chat for how can we maybe use this to generate different types of mocks for unit tests. Now, I think there's lots of other different directions this could go, like back to my bad ideas. I start with bad ideas so that somebody can come up with a good idea. But the bad idea is, you could mock half of it, right? You could virtualize or create a component of the one side, which is the part that runs as a WebAssembly component. But your actual code, you could compile that as a native binary. Nothing's stopping you once those interfaces are fulfilled, even though they're fulfilled via mocks and some other system. And then you would have your native tools, just like you're used to, and we don't even have to modify them at all. There's the actual not bad idea, the right answer here, which is okay, well, we'll come up with a full complete system for having native debugging across components, like dwarf style debugging. Like, yes, I want that, but I will say that as somebody that has to solve this problem, like in this moment, for a lot of the things that I build, I fall back to I compile my code as native with my native tools in my debugger, and then I use some other different types of testing, like integration tests for other problems that I'm solving. And I think there's also a space here that I would love somebody to build that weird hybrid that I just proposed as the bad idea. That's just another space that I think would be really powerful, and would enable a ton of different tools and would be able to be used across any language. Okay, all right. I'm going to stop coming up with brainstormy bad ideas. We're at the top of the hour. Joel, thank you so much for hanging out. I learned a lot, and I've been following this as tight as I could, which is awesome. And you're just a wealth of knowledge. So thank you. I really enjoyed having you. And everybody else, see you next